Alô? Boa tarde. Eu gostaria de dar início à USP Lecture. Por uma questão de cortesia, eu vou passar em inglês. So, good afternoon. I'm Paulo Nussensweig, currently Provost for Research and Innovation at the University of São Paulo. I'm thrilled to welcome you to another USP Lecture, a series which has been organized by the Office for Research and Innovation for many years now. And even though I'm not a huge fan of this venue for these lectures, because it's kind of inaccessible, and so the fact that we have a pretty full house shows how interesting the subject is and how people are drawn to come to this subject. It's a huge pleasure to have Professor Bernard Wood here today. He will be introduced by Professor Terra. I want you to enjoy the lecture. Unfortunately, myself, I have travel tonight, so I won't be able to stay, but it's definitely my loss. So, Professor Terra, please, to introduce our distinguished speaker.
Professor
Neves. You see, I'm traveling tonight, so Professor Neves, wow. Fortunately, you understood I was referring to you.
Ok, no problem. Bom, eu vou falar em português mesmo, já que a plateia é basicamente tupiniquim. O Bernard Wood é médico de formação. Bom, primeiro que eu quero dizer o seguinte, tudo que ele publicou, não é, virou clássico na nossa área, absolutamente tudo. Não é? Então, o Bernard Wood é professor titular de evolução humana na Universidade George Washington, nos Estados Unidos. Em 1968, juntou-se à primeira expedição de Richard Leakey, não confunda com Louis Leakey, não é? Ele se juntou à primeira expedição de Richard Leakey na bacia do Lago Turkana, no Quênia, e posteriormente acompanhou o grupo de pesquisa que trabalhou com os hominíneos recuperados no leste do Lago Turkana. Né? A pesquisa no Lago Turkana, que a gente chama também de Koobi Fora, ou a formação Koobi Fora Formation, né? Foi uma das mais pródigas expedições e projetos paleoantropológicos já desenvolvidos no planeta. Ele publicou 252 artigos científicos e capítulos de livros, além de mais de uma centena de pequenos artigos e comentários. Ele é autor ou coautor de 20 livros, incluindo uma importante monografia de 1991, exatamente sobre os restos cranianos dos hominíneos da formação Koobi Fora no Quênia, que se tornou um clássico, como tudo mais o que ele fez, não é? Um atlas de anatomia dos tecidos moles dos monos. Quando eu falo monos, eu estou falando de chimpanzé, gorila e orangotango. Monos corresponde àquilo que em inglês a gente chama de apes. E um livro não técnico para o grande público chamado Human Evolution, A Very Short Introduction, para o público em geral. Ele é o editor da Enciclopédia da Evolução Humana e é mais conhecido por suas pesquisas sobre as origens do gênero Homo. Não confundam com a origem do Homo sapiens, que são duas coisas muito distintas. Né? Então, ele é especialista na questão da origem do gênero Homo. Na paleobiologia do Paranthropus boisei, que é um dos nossos, não é propriamente o ancestral, é uma linha colateral, a sistemática dos hominíneos e a reconstrução da filogenia, da morfologia comparativa e a epistemologia na paleoantropologia. Sua pesquisa foi citada mais de 20.000 vezes com um índice H de 80 e um índice I 10. Em 2023, ou seja, esse ano, o Bernard Wood foi agraciado, uma das honrarias que um cientista pode receber na nossa área, né? Ele foi agraciado pelo conjunto de sua obra com o prêmio do presidente do Instituto Antropológico Real do Reino Unido, como eu disse, uma das honrarias mais importantes da área de antropologia. Isso aconteceu recentemente. Uma vez que é requisitado por todo mundo por suas palestras magistrais, sua presença hoje no Brasil me custou 30 anos de insistência. Ou seja, faz 30 anos que eu insisto para o Bernard Wood vir nos visitar. Durante a sua estadia no Brasil, ele vai proferir 2 conferências, essa, e uma manhã no auditório, com temas distintos, uma manhã lá no auditório da FAPESP, não é? Ele vai orientar alunos brasileiros na área de paleoantropologia. Nós estamos com uma série de pesquisas na área com alunos de graduação, e ele vai discutir as pesquisas desses meus alunos de graduação, e vai visitar, né, conosco a região de Lagoa Santa, que é o berço da arqueologia brasileira. Senhoras e senhores, Bernard Wood. Please, Bernard.
Well, first, I hope you will accept my apologies that I will be speaking to you in English, or a sort of mixture of an American and English, and I apologize for that. I also want to thank Walter for his kind invitation, and to Andre Strauss for his hospitality and his kindness. And I've only been here a day. Okay, so many thanks. I want to talk about the origins of the genus Homo, and I want to begin by just reminding you that the genus Homo was the brainchild of Linnaeus, and Linnaeus was he was a Swede, and at the time, Sweden really rivaled Portugal in being a maritime nation. And although they didn't have as many colonies, they reached a lot of the world, the Swedish merchants and explorers. And so they were bringing all this stuff back, and they were putting it into museums, and the museums were used to organizing the material from Sweden and Europe, but they weren't used to organizing material from all over the world. And so they needed a classification scheme to organize this material, and that's what Linnaeus really came up with. I mean, it's a gross oversimplification, but that's what he came up with. And the original Linnaean taxonomy included not only living things, but also rocks and inanimate objects, but that's not the way it's used now. So he introduced the genus as the category above the species, and he introduced the genus Homo for modern humans, and he called us wise people, so that's the meaning of Homo sapiens. The genus, so it started with only having modern humans in the genus. And then in the mid-19th century, the Neanderthals were included in the genus Homo. Now, Neanderthals, if you saw a living Neanderthal, which I don't think you're going to, but if you saw a living Neanderthal, My guess is that they would look a little strange, and that if they got on the bus, you would probably move your seat and go to the back of the bus or the front of the bus. But I don't think you would recognize them as being sort of people roughly like us. And then more species were added to the genus Homo, more the remains that were being discovered in Europe, and then Africa, Homo rhodesiensis, and then the Far East, Homo soloensis. So these species were added to the genus Homo, but there was a sort of a general feeling that they were human-like enough, modern human-like enough, that they didn't stretch the definition of the genus Homo really uncomfortably. And the analogy I like to use is like a sort of stretch limo. You know, you start with a car with 4 doors, and then you stretch it a bit, and then it's got 3 doors on each side, but it still looks sort of like a car. Okay. And then the biologist Ernst Mayr suggested that material that had been put into a different genus, Pithecanthropus, was included in Homo, and this was a proposal that was made during the Second World War. So the genus Homo expanded a little more. It got a little more inclusive, but it still made reasonable sense, except that the brain size of Homo erectus was quite small. It was well under 1,000 cc's. But people were reassured by the fact that the thigh bone that was found at more or less the same time, that seemed very modern human-like, and that's probably because Josie Jordan and her team have discovered that it was much later than the fossil, which is which has the small brain size. So on April the 3rd, 1964, this is what a sort of chart of early hominins would have looked like. And you can see, and when you see this diagram, the vertical axis is always going to be the same, which is in millions of years. And then the horizontal axis is a rather informal axis with hominins with large brains like ours over on the left, and hominins with large molars and premolars very much not like ours over on the right. So that's how you spread things in the horizontal axis. And the columns are, the bottom of each column is what's called the first appearance date. In other words, the earliest fossil evidence for a hominin. And the top of the column is known as the last appearance date, which is the most recent fossil evidence for the hominin. So on April the 3rd, 1964, that's what the understanding of Homo was. And then on April the 4th, there was the publication of the paper by Richard Leakey and Philip Tobias and John Napier, suggesting that there should be an additional species added to the genus Homo. Now, there was a lot of controversy, and I'm going to go through some of that controversy in the lecture this afternoon. So in order to include the material, which I will show you in the genus Homo, they sort of had to change the rules. And so I'm a great one for metaphors, which are sometimes even more confusing than the thing I'm trying to explain. But imagine that the genus Homo was a tennis club, okay? And in order to get into the tennis club, you had to show a certain amount of skill. And so you were tried out to see if you merited belonging to the tennis club. What Leakey, Tobias, and Napier did was that they revised the entry conditions for the tennis club. And so you didn't have to be as good a tennis player, but you were still allowed into the club. And they revised the conditions in a way that I will talk about a little later this afternoon. So what led to the proposals that they made in the 1964 publication? Because what they proposed was that this material, which they called Homo habilis, which means handyman, because the assumption was that Homo habilis had made the stone tools which the Leakeys had been finding at Olduvai Gorge. Now, when they published Homo habilis in 1964, they immediately relegated Zinjanthropus boisei, which they had found in 1959, and because it's the only hominin that they had found at Olduvai, they suggested that Zinjanthropus boisei had made the stone tools, which were found in the same layers at Olduvai. Once they discovered the material which they included in Homo habilis, they thought that this creature was smarter than Zinjanthropus boisei, and therefore they dumped Zinjanthropus boisei that had an extremely illustrious but very short career as the manufacturer of the stone tools between 1959 and 1964. So they believed that if Homo habilis was the maker of the stone tools, then Homo habilis must have been had enough dexterity to make the stone tools. It must have had enough cognitive ability to understand that it needed to make the tools, and it knew how to make the tools, and so on and so forth. They also assumed, because of their interpretation of some of the bones that they found from the foot, they assumed that it was a biped. And so they made all these assumptions, and they worked all these assumptions into their revised diagnosis of the genus Homo. So this is the material, this is the first material from Olduvai. Now this was discovered OH4. You don't have to be a brilliant mathematician to realize that OH stands for Olduvai hominin, and Olduvai 4 was found before OH5, which was the type specimen of Zinjanthropus boisei. So they found these teeth, and then a few weeks later, they discovered the cranium of Zinjanthropus boisei. Now, the cranium completely, that became the main point of interest, and they didn't really look very carefully at OH4. After OH5 was found, and they spent time reconstructing it, and it was published, they then discovered OH6, which was just some fragments of the cranial vault and some teeth. And then they found OH7, which was very unlike Zinjanthropus boisei. You and I have mandibular molar teeth which are about the same size as our little fingernail. Just happens to be that way, okay? The molar teeth of Zinjanthropus boisei are about the size of your thumbnail, and to give you some idea of how much larger they were. So these teeth in the jaw on the bottom left, they were much, much smaller than the chewing teeth of Zinjanthropus boisei. And the cranial vault, which is not that impressive, which you see on the top left, that didn't have the sort of crest that Zinjanthropus boisei had. And they also found the foot OH8. Now, we don't know this belongs to Homo habilis, and some of us think it might actually belong to what we now call Zinjanthropus boisei, which is Paranthropus boisei. But nonetheless, at the time, they thought that this belonged to Homo habilis, and this was the reason why they said it was erect, and it was a striding biped. And you must understand that striding bipedalism is sort of this. It's not this. So they suggested that it was a striding biped. And then they found some more material. They found OH13, which is a cranium with an upper jaw and a lower jaw. And they found OH16, which is a cranium which has as much plaster as it does bone, but nonetheless you can see roughly what size and shape it was. But it has a nice dentition. So Louis Leakey had found these fossils. He and his family had found these fossils. He had already asked Philip Tobias, who was the professor of anatomy at the University of the Witwatersrand in southern Africa, to describe the type specimen of Zinjanthropus boisei, which was OH5. And so he invited Philip Tobias, and then because they had the foot bones and some hand bones, there was an anatomist in London called John Napier, who actually taught me primatology when I was a medical student. John Napier was invited to help describe the limb bones. So Leakey, Tobias, and Napier, they were the authors of the 1964 paper. So that's a background really to the rest of the lecture, and the questions I want to ask is, okay, what is a genus in any case? Okay. What did Linnaeus mean, and what do we mean today by what a genus is? Which taxa should be included in our own genus Homo and why? And when and where did Homo originate? So these are the questions that I want to race through for the rest of the talk. And I want to make sure that you understand that a lot of the work that I'm going to be talking about today was done by graduate students, and they include Andrew Dew, Eve Boyle, and Mark Collard, and David Patterson. And you'll see pictures of those later on. So what is a genus? My sense was that this would have been worked out a long, long time ago. And so when we started to think about this, I thought, all you need to do is to go to the literature and there will be a well-accepted definition of what a genus is. And of course, like all one's expectations in science, there wasn't a well-accepted definition of what a genus was. And so I did some work with Mark Collard, and we came up with a definition. And basically what we suggested was that a genus, the species in a genus needed to be in the same clade or monophyletic group. Neither of those words are terribly helpful, and I will try and help you understand what a clade and monophyletic group is. And the other thing that we suggested was that the species in a genus should be in the same grade, and I will try and help you understand what we mean by the same grade. But let's start with the same clade. And basically, what we suggested that a genus should be a clade, and a clade is all of the taxa, all of the species, no more and no less, that are descended from a recent common ancestor. Now, I can tell from the excited look on your face that that is really helping you understand what a clade is. But let me sort of help you a little more. So So my colleagues make fun of me because I use analogies and metaphors from motor cars, and let me explain. Really, a clade is a make of motor car. After the Second World War, when Japan was soundly defeated, the Japanese had no motor car industry. They never had. All the cars that they used in Japan were imported. So they decided to start a motor car industry, and they looked for a company that was already used to making things. And so there was a company called the Toyota Company, which made machinery to make cloth. They made machines that wove cloth. So they got the government instructed that company that you should now look into making motor cars. And so they started what is known as, you and I know, as the motor company, which the D was replaced by a T. So this, before the Second World War, they had this thought, but the Second World War delayed all this. So after the Second World War, they, in the mid-1930s, they had made a prototype, which is this car here, which is called the A1, the Toyota A1. So that is the common ancestor of all motor cars made by the motor company Toyota. We know that because there is the historical information that that is the most recent common ancestor of all motor cars made by that company. So that seems to me to fit the definition of a clade. So what about a grade? Well, a grade refers to how you make a living as an animal or a plant. Do you eat meat? Do you walk around on all fours? Do you graze grass or do you graze leaves? This is what we mean by a grade. And so it's a group of taxa that shares a suite of adaptive features. In other words, the same grade of animals will be animals that are in the same adaptive zone. So to go back to my motor car analogy, the cars and the SUVs made by the Japanese company are on the left, and the SUVs made by an English company. I think it's no longer English, but it used to be English. The English Land Rover company are on the right. The SUVs are all in the same adaptive zone. Sport utility vehicles have a high ground clearance. They normally have the capacity for four-wheel drive. They're more rugged than a passenger motor car, and they're meant to be used in rugged circumstances. So it always amuses me to see them being driven around Washington, D.C., where you really, unless you go to parts of Washington where the roads are really bad, there is absolutely no need to have a sport utility vehicle at all. But so that's what unites the sport utility vehicles. So the Toyota Land Cruiser is a sport utility vehicle, the Land Rover Freelander is a sport utility vehicle, and the Land Rover Range Rover is a sport utility vehicle. But you can see that They belong to different clades, okay, but they are the same adaptive, they're in the same adaptive zone. So, and they share a common ancestor, but my guess is that the common ancestor they share is probably the original Daimler Benz that was made in, in the late 1800s. But it wasn't a recent common ancestor. So to go back to my motor car analogies again, if we look at the sport utility vehicles made by the Toyota Motor Company, we know what the original one was. It was a copy of the Willys Jeep that the Americans had so successfully used in the Second World War. And so they just made a copy, and it was called a B1. Yes, it was called a B1, not a B1, a BJ. So that was the most recent common ancestor of all the sport utility vehicles made by the Toyota Motor Company. And this is what the BJ looked like. And so it was the beginning of a new adaptive strategy for the Toyota Motor Company, but that adaptive strategy was also adopted by other motor companies. So you can't use the fact that some things are sport utility vehicles to group them together in a clade sense. So you saw this history of the sport utility vehicles made by the Toyota Motor Company, but supposing the only evidence you had of the BJ was a little bit of the windscreen, part of the wheel, some various bits and pieces. So our problem in paleoanthropology is we don't have whole motor cars. We have the parts of motor cars, and from those parts of the motor cars, we have to try and come up with hypotheses about grades and clades. And that is the difficulty. So if a genus needs to be both a clade and a grade, which taxa should be included in our own genus Homo and why? So basically, what are the clade-related reasons and what are the grade-related reasons? And they're not necessarily the same. So here we are, back to 1964 and Leakey, Tobias, and Napier. So how have the proposals that they made in 1964, how have they withstood the evidence which has been accumulated since 1964? So what is that evidence? Well, there's no way I can cover all of the evidence, but I'm just going to give you some highlights. One is an associated skeleton, which was found at Olvi, which has a dentition which is clearly much more like Homo habilis than it is Zinjanthropus boisei. And so we now have, a little bit of evidence about limb length. But as you can see from the fossils, they are annoyingly incomplete. They are complete enough to make you think that you might know something about relative limb proportions, but they're not really complete enough to actually give you a lot of reliable information. There is also a whole collection of fossils which was recovered from Koobi Fora on the east side of Lake Turkana and on the west side of Lake Turkana, and also from the Ishungura Formation north of Lake Turkana. So all that material is relevant to this discussion. And then one of the things I had to do was to try and make sense of all this cranial material, and that is in a monograph which was published in 1991 that took me a long time to put together. And so one of the hypotheses in the monograph was that, so in other words, was there just one species, just Homo habilis, or were there two species that might be considered for inclusion in the genus Homo? And what I concluded was that it was more likely that there were two species represented in the fossil record from Koobi Fora, but you couldn't eliminate the possibility that they were all in the same species. And then there are a whole bunch of fossils which were found in southern Africa, which were, when they were published, they were put forward for consideration as belonging to Homo habilis. And they include STW 53 from Sterkfontein and SK847 from Swakrans. So how did the addition of all this material, how did it affect the argument about being in the same monophyletic group, in the same clade? Well, the answer is that most people who do analyses which try and relate hominin species in monophyletic groups, most of those results would group Homo habilis with later Homo. So in other words, most analyses would come up with results which would satisfy the clade criterion for including Homo habilis into the genus Homo. What about the grade criterion? In other words, was Homo habilis the same sort of animal as Homo erectus? Or was it more like Australopithecus africanus or Australopithecus afarensis? And what Mark Collard and I tried to do in a publication in 1999 was to look at this, at the various aspects of the grade criterion. And what we did was that we argued that if they were in the same genus, they shouldn't be crazily different in body size. Okay. We also argued that the limb proportions, if they're going to be in the same genus, should be roughly the same. In other words, you shouldn't put in the same genus a creature that had long legs and relatively short arms with creatures that had relatively longer arms and shorter legs. That didn't make any sense. They were clearly doing something different. And and we also argued that in terms of jaws and teeth, you shouldn't put in the same genus a species that had large teeth in the same genus as a species with relatively small postcanine teeth, and that the animals in the same genus should really develop with the same developmental program, and that their brain size should be roughly the same. Now, you can disagree with these criteria, but those were the criteria that we set out. And when we did that, and you looked at Homo habilis, the A's stand for more like Australopithecus, and the H's stand for more like Homo erectus. And what we concluded was that Homo habilis was more like Australopithecus than it was Homo erectus. So in terms of its performance and its capacity, we argued that it was probably should not be put in the genus Homo. And this sort of went down like a lead balloon, I have to say. But nonetheless, that's what we suggested. So if everybody else was right, then this material, the two species that one was called Homo rudolfensis and the other was called Homo habilis, they should both be in Homo. If we were right, they should either be in their own genus or in the genus Australopithecus. And you can tell who won because everybody continues to think that they're in Homo. Okay, so what has happened since we made that attempt to try and do something in 1999? Well, there's been more fossil evidence, clearly since 1999. And the cranium that you see in this illustration was discovered in 1972, but the mandible below was discovered much later. Nobody's suggesting that the mandible belongs to the same individual as the cranium, but nonetheless, it clearly is really likely to belong to the same species as the cranium. And then more material found at Koobi Fora suggested that there was a smaller bodied version of 1470 which really gave support for the 2 taxon explanation instead of just the 1 taxon explanation. And then this mandible was recovered from a site in Ethiopia, and the people who recovered it, they made an argument that this mandible wasn't like the mandibles of Australopithecus afarensis, many of which have been found not far away from this location in Ethiopia. So they argued that this might be a very early member of the genus Homo. And since 1999, there's been quite a lot of work looking at the grade criterion. In other words, looking at the evidence for cognition, looking at the evidence for dexterity, looking at what evidence we now have for diet. And to talk about locomotion, most of the papers that have been published since 1999 about the possible locomotion of Homo habilis have all suggested that its locomotion was probably more like the locomotion and the posture of the Australopiths than Homo erectus. So this is not my work, but this is the work of people who have independently looked at this. And there's a very nice paper by Chris Ruff, who looked at the cross-sectional area of the humerus and the cross-sectional area of the femur. And there's a real difference between the relative cross-sectional area of the humerus and the femur in modern humans and something like a chimpanzee. In modern humans, we have much more bone in the femur than we do in the humerus. This is probably a mixture of genetics and activity, and Chris Ruff did a very nice paper looking at the cross-sectional area of the humerus in professional tennis players, and he showed that the racket arm, there was a larger cross-sectional area of the humerus than in the non-racket arm. In other words, these people had the same genome because it was one right arm and one left arm. And so it was a nice controlled experiment, but it showed that sort of clearly this had something to do with how much you used your forelimb to support your weight or to do whatever, and how much you used your hind limb. And he showed that in OH62, the cross-sectional areas of the long bones were more like chimpanzees than they were like modern humans. I think that's a really nice piece of work. Then one of our graduate students was the driving force behind a look at the evolution of brain size in the hominin clade. And there was conventional wisdom that there was quite a sharp increase in brain size between Australopiths and Homo. And a lot of textbooks had this sort of shift in brain size. It was one of the things that they really emphasized. What Andrew Dew and a bunch of graduate students did, and this was in a class where this was a class for the graduate students, where what we did was to take a data set, a well-known data set, and look at it with some sort of degree of sort of skepticism, because once everybody agrees about something, then that seems to me the time to look at it, because everybody's relaxed about it. Oh, you know, we all know that brain size increases in Homo habilis. We all know. So whenever you hear the phrase, we all know, that's a really good reason to look at it, okay? Because probably we all don't know, okay? So what the students did was that they looked at all the brain size data. And they looked at all the brain size data, and they looked at the error in the estimation of brain size. And they looked at the error in the date of whatever fossil they were looking at in terms of endocranial volume. So when you account for these errors, the whole thing looks rather different than when you don't account for the errors and you just have a point, which is the endocranial volume at that age. So when you account for the error, it really changes how these data look. And so what they did was that they examined whether, you know, the data were just an example of random walk. Were the data an example of gradualism? Were the data an example of what's known as punctuated equilibrium? In other words, were there periods of stasis and then a rapid increase in brain size? And basically, the data, the data were much more consistent with gradualism. In other words, without a punctuated event at the origin of Homo than they were anything else. And it wasn't even a close run thing. It was, you know, sort of gradualism completely won the day. So that sort of also argues that nothing special happened to brain size when Homo habilis appeared. Then we come to diet, and this is the work of David Patterson. And now you can recover stable isotopes from the enamel of teeth, and you can work out what sort of food these creatures were eating. And you just have to take my word for it that the animals that were mainly C3 were mainly browsing on leaves, and the animals that were C4 were mainly grazing on the tropical grass. So what David Patterson did was that he looked at the evidence from the Turkana Basin. And the first thing he did was to look at the stable isotopes in the fossil soils. So in other words, you want to make sure that the vegetation that was available over the million-year period that he was looking at wasn't changing, because if the vegetation changed, then clearly the diet, you know, would change in response to the vegetation. But basically, there wasn't a lot of change in the stable isotopes in the fossil soils. So this is much too complicated for you to see, and it's crazy for me to put it on the screen, but it just reminds me to tell you that something like there were two hominins. There was Paranthropus boisei. There is evidence for Paranthropus boisei throughout the million years of this record. The stable isotope signal for Paranthropus boisei does not alter in the million years. It started out as C4, and it ended up as a C4 consumer a million years later. And we think it was actually mainly eating either grass or vegetation which was growing around water sources, which is also C4. When you look at Homo, for the first half of that period, it was more C3. And then for the second half of that period, it's more C4. Now, Homo doesn't change the tooth size in that period. It doesn't change the jaw size in that period. Well, actually, it does change the tooth size a little, but not as, it doesn't become like Paranthropus boisei. So there is a reduction in the size of the chewing teeth in the latter half of that period, and there is a reduction in the amount of bone in the mandible in the latter half of that period. And the hominins, which we would put and everybody else would put into Homo ergaster/Homo erectus, have a more C4 signal than the hominins that everybody would put into either Homo habilis or Homo rudolfensis. So what on earth's going on? Well, when there is a shift in Homo from C3 to C4, and don't forget, Mark Collard and I wouldn't call them Homo with the more C3 signal. When there's a shift, that's also when you begin to see archaeological sites with artifacts that you could argue were used for butchery. And so we think the Homo in the latter part of that million years, they had a C4 signal because they were probably eating animals that ate grass, not because they were eating grass, because their dentition, it just wouldn't make any sense that they were eating grass. So, when did Homo begin? Now, that is a problem because these columns, I said, the bottom is the first appearance date, in other words, the earliest evidence in the fossil record, and the top of the column is the last appearance date, which is the most recent evidence of that taxon in the fossil record. But the problem is the first appearance date is not the day or the month or the year or the decade or the century or the millennium that these creatures first appear. It's the first time you find them in a fossil site. And if you have no fossil sites which are older than your first appearance date, it makes no sense to interpret the first appearance date as when those things emerge, because you just don't have any evidence before that. So it's like saying, I think this road traffic accident occurred at midday because I was there at midday, but I wasn't there from 6 o'clock in the morning to midday, so when, I had no idea when the road traffic accident. All I know is that when I got there at midday, there was an accident. That's not to say it occurred when you got there. So the when question is extremely difficult to answer, and it is not the bottom of those columns. It's clearly older than that. And the question is how much older? And that is a problem that we have been working on, and there's no time for me to go into it, but the point is, it's not the bottom of the columns. It's sometime older. So there is no point in going around and sort of looking at the paleoclimate record and saying, there's a wiggle in the oxygen isotope record that coincides with the first appearance of Homo. That's the reason why Homo appeared. That's really dumb. Okay. It might be sort of instantly satisfying, but it's really dumb because that's not when Homo appeared. It would have appeared, it must have appeared earlier. So each column is a hypothesis about the existence of a taxon and the ages of the existing site samples of the taxon. It's not the observed first and last appearance dates are just that. They are not the actual first and last appearance dates. And the reasons for that are quite complicated, and we've been doing some work on other taxa. And so what the columns are not sort of take to the bank statements about the timing of the origin and extinction of each of these taxa. It's really difficult to convince people of that. So, so this is from a relatively recent paper with René Bobet, and you can see the, the possibilities for the first appearance of Homo. The statistical possibilities actually go all the way back to 3 million years. So one needs to take that into account. Where did Homo originate? Well, I used to have lively discussions with Richard Leakey, who there was all this evidence for the Turkana Basin, and maybe Homo originated in the Turkana Basin. No, it's just where you find the fossils. I mean, it doesn't mean that really interesting things weren't going on 1,000 miles away, and it doesn't mean that the range of the fossils was constrained by where you find, the range of the creatures was not constrained by where you find the fossils. The reason that you find the fossils in the Rift Valley is because of geological contingency. It's not anything to do with, oh, that's where they were living. They were probably living far and wide beyond the Rift Valley. So where is a really difficult problem to answer, especially when all we know about the presence of fossil hominins in Africa comes from sites which, at the most generous estimate, represent about 2% of the land surface of Africa. So if you're prepared to come up with a hypothesis about where Homo originated on the basis of evidence that only comes from 2% of the land surface, then I don't know, doesn't seem to me a smart thing to do. So the where question is really difficult. Some people think, that it's 3.5%, but that's really, really generous, but you need to include the sites in Chad and the sites in Southern Africa. So given that we don't know what evidence is missing, we know the evidence we have, but we don't know the evidence we don't have. Now, you may say, well, why are you worried about that? Well, you need to be worried about that, because you can't come up with a narrative which is based on the evidence which we have for a whole lot of contingent reasons, none of which are probably to do with the nature of the creatures that you're trying to investigate. So what should we say about the origin of Homo, which is, the reason that you came to this lecture? Well, I think, like all questions which are to do with origins, it's really challenging to answer scientifically. I can explain to you where the evidence is. I can explain to you how old we think the evidence is. But there's a whole lot that I don't know. And because I don't know it, I have to give you a caveat to say that really, we don't know when, we don't know where, and quite obviously, we don't know why. Okay. We can answer the why questions for the regions where we find the fossils, but we don't know the why questions that relate to, the range of these hominins, which was surely more extensive than the Rift Valley. And I've been doing some work recently with Andrew Barr, who is a colleague at GW, where we are looking at modern animals that are found in the Rift Valley and asking the question, if the only thing you knew about the ranges of those modern animals and their habitats was the habitats that they were living in the Rift Valley where they're found today. How much would the knowledge of where they were living in the Rift Valley, how helpful would it be to tell you about their larger range and habitat? The answer is about 30% of the information. And we also did the same thing looking at morphological variation of primates, specifically baboons and guenons, which are known from the Rift Valley, but they're also known from elsewhere in Africa. These are contemporary primates. And also, the variation that will be captured by the primates that you measured that come from the Rift Valley will give you about between 30 and 35% of the variation that's expressed in their total range. So you know, one needs to be careful. Before I finish, I just want to pay credit to people who were the main sort of drivers behind the expedition, the East Rudolph Research Project that became the Koobi Fora Research Project. The co-leader was an archaeologist called Glyn Isaac, who was just a wonderful person who died very tragically in 1985. And last year was not a good year for the Koobi Fora Research Project because Kamoya, who's on the left here, he passed away. He was a wonderful guy who'd been working with Richard since 1963 when Richard first went to Lake Natron. They were, Kamoya was Richard's right-hand person in the field. He was a wonderful person, and he passed away last year, and of course Richard did too, and I have to say I owe my career to Richard, and I just want to acknowledge that, and I want to thank you for coming, and I'm happy to ask any questions, but you're under no obligation to look interested. Okay? Many thanks. Yes. Is that a hand raised? No. My eyesight's not terribly good. So.
Alguém com a mão levantada?
Bom, eu acho que nós dá para ouvir? Eu acho que nós temos tempo para umas 3 ou 4 questões. Então eu peço que as pessoas restringam as suas questões a 2 minutos. And Bernard, you have 5 minutes to answer the questions.
Okay.
Okay? Se as pessoas pudessem se identificar, seria ótimo.
I am Santiago Guimarães, a student in paleoanthropology. And sorry about my bad English now, but I'm trying to be understood. Thank you very much for being here, sharing ideas about the birth and development of the Homo genus with a very intriguing and complex questions about all origins. Well, I would like to ask you the following question. It's still problematic question. It was the Homo genus formed by one unique and single evolved lineage, or it was a multiple species hypodigm? I ask you this because we have in these moments 2 groups in the world and universities that discuss these problems. One group formed by, for example, Leakey in California University and Timonese teams in Republic of Georgia believes that there is just one unique single lineage. And on the other hand, we had Annenberg, for example, in Australia, and others that believes, the Timonid groups believes also that we have just one lineage. But the Leakey's groups believes that we have multiple species. What do you think about this? Sorry, but...
No, that's I think, perfectly understandable. I mean, what I showed you, the diagrams with all the columns on, was a very specious interpretation of the fossil record. Now, that is my inclination. I think it's better to recognize, if there's a choice, more species than less, because you can always merge species together. It's really difficult to take an inclusive species and separate or divide it. But even if you adopt a very lumping philosophy for your taxonomy, there is really no way of interpreting the fossil record from about 4.5 million years ago until the present without recognizing some sort of taxic diversity. And what I mean by taxic diversity is more than one hominin species living on the planet at the same time. Now, your question is directed to Homo. In other words, what do you think is going on in Homo? My feeling is that it's very difficult to interpret the fossil record, which most people would agree probably should be included in Homo, without recognizing more than one species at, around 2 million years. It's really difficult to put all that material into a single species. Now, it would take me a long time to give you the reasons why I think that. But this is not because either I'm stupid and they're right, or they're stupid and I'm right. It's perfectly possible to look at the same evidence and to come to different conclusions, as long as you explain the basis on why, the reason why you came to the conclusion that you came to. So I think there will be inevitably disagreements about what we call alpha taxonomy. That doesn't mean that paleoanthropologists sort of don't know what they're doing. It just means it really goes back to my picture of the BJ Jeep, the whole Jeep, and then, the Jeep, just sort of bits of it. If we had whole skeletons with whole dentitions, then I don't think there will be as much disagreement as there is now, because we're trying to come to conclusions based on not the best evidence, but it's the evidence we have.
Thank you, Bernard. Next question.
Thank you, Professor. My name is Gabriel Rocha. I'm one of Professor Walter's students. So I wanted to ask you about, we have these two conditions to include a species in a genus, so the same clade and the same grade. And taking into account these ecological adaptations, I would like to ask you about the rising star cave material again. And what do you think about Homo naledi? So they have those long arms and small brain case. So should we be classifying them as Australopithecus? Maybe, but they have 200,000 years. So what do you think about it?
My sense is that the hominins that were discovered in the Rising Star Cave are a relict population of Australopiths that were in South Africa. South Africa is surrounded on 3 sides by ocean. It's North of it, the habitat wasn't conducive, it wasn't particularly kind to hominins. So my guess is that southern Africa was really behaving like an island, and that this is a relict group. And if it was me, I wouldn't put them in Homo.
Well, our results are showing that Naled is Homo,
Okay.
and not a relict of Australopithecus.
Okay.
Okay?
See, it just goes to show how wrong I can be. Okay.
Next question.
Walter, you're after another victory. Okay.
Santiago, I'm sorry, speaking Português. Santiago, a gente terminou de fazer uma análise mostrando que em Dimanize você tem 2 espécies, tá? Vamos ver se a gente consegue publicar isso. Tá bom? Questions? Okay, so thank you very much, Bernard.
Thank you. Thank you.